Hello and welcome to another lesson. In this lesson, we're going to talk about multiplication of positive and negative numbers. We're going to be talking about indices. We're going to talk about decimals, multiplication of decimals, addition of decimals, and subtraction of decimals. So we'll move straight to talking about multiplication of positive and negative numbers. Whenever you have two positive numbers, like this example, have positive times positive gives us positive, negative times negative gives us positive, sorry. Positive times negative gives us negative, negative times positive gives us negative. So let's take example from the first one. We have two positive numbers, let's say plus 2 times plus 4. It can also be written as 2 times 4, which is equal to 8. So this 2 and this 4 and 8, they all have some invisible positive numbers in front of them. So when it's positive number, most of the time we don't write plus 2 and times plus 4 equal to plus 8, because they are positive, so most of the time we don't get to write them. But negative numbers, we need to write to differentiate it from the positive by putting negative. So if you have minus 2 times minus 4, it will surely give you plus 8, because you have minus here and you have minus here. So following this rule, you will now have plus 8 as the answer. From this example, the third one, you have plus 2 times minus 4 will give us, since remember this rule, plus times minus will give you a negative answer. So minus 8, so minus 2 times plus 4 will give you minus 8 as well. So you can see the differences. So now let's move on to indices. Remember we've talked about BODMAS in the previous video. If you don't know about BODMAS, I have a video on BODMAS show. I recommend you to watch it and learn more about BODMAS. But talking about BODMAS, we're going to concentrate on off, because it pertains to indices. Power off, power off, that is off here. So now, talking about indices, there's what you call law of indices. Laws of indices. When you have a number like 2 raised to the power 3, 3 is the index of 2. 3 is the index of 2. Plural of index is indices. So what this means is that you have 2 times 2 times 2. That's 2 in 3 places. That's what it means. 2 in 3 places. So that's explaining what index and indices means. So let's go to one of the laws of indices. It's not arranged in any particular order, but I would like to arrange it according to BODMAS. Starting with the one that has brackets. So if you have a number like, let's say P represents a number, then M is the power, that's the index. Then you now have, in brackets, you have N. To solve this problem, the law of indices says that you need to do M times N. For example, if you have 2 raised to the power 3 in brackets, all of them raised to the power 2 again. So you have to do 2, then 3 times 2, and not 2 raised to the power 3 plus 2. Okay, this is, if you do it this way, it's wrong. For this case, if you do it this way, it is wrong. Okay, then, and not any other thing, maybe like 2 raised to the power 3 minus 2, this one is also wrong. Okay, so you have to follow this rule, and the rule says then there's a bracket and the powers, the indices are like this. You have to multiply. So the next law of indices requires us to let's say we have P over S. Okay, have P over S, then all raised to the power M. It requires you to open the bracket. When you open the bracket, this M times power 1 will give you M. Then this M affects the one at the base too. Okay, so for example, you have, let's say, 3 raised to power 3 over maybe 4 all raised to power 5. Okay, to solve this problem, you have to do 3 raised to power, let's say there's an invisible one here and there's an invisible one here. So you now say 1 times 5, because you're opening up the bracket. Remember the other law of indices that says that you need to do P raised to power N like this. Okay, so P M times N. Okay, so you're opening this bracket, so you do this times this. Okay, then you now go back and do 5 times the power here, so the index here, sorry, 1 times 5. Okay, so altogether you get 3 raised to the power 5 all over 4 raised to the power 5. Okay, so we'll go to the next law of indices, which says P, for example, P M over N. Okay, so if you have such, you're required to put N outside, so you're finding the roots of P raised to the power M. Okay, roots P raised to the power N, M, N roots P raised to the power N. So you can say it as N roots P to power M. This is how you say it. If you have something like 2, okay, you say square root of P to power 3. Okay, sometimes you can write, this can be written as P raised to the power 3. Well, if there's no 2 here, that means you just know that it's square root automatically. If it's 3 P raised to the power 3, you say it as cube root of P to power 3. Okay, and so on. So if it's 4, so you say 4 roots P to power 4. This is how you say this. Okay, this is how you say this. For this one, you say cube roots of, for this other one, you say square root of, for something like this, you say N root P to power M. Okay, so let's move on to the next law of indices, which says that you have, if you have something raised to power 1, let's say P raised to power 1 should give you P. Okay, whatever number raised to power 1, let's say it's 1000 raised to power 1, gives you that same number. Okay, so that's simple enough. So for the next law of indices, you have P raised to power 0 equal to 1. Similarly, if it is 1000 or 1 million raised to power 0, whatever raised to power 0 gives you 1. So those are the rules you should remember, law of indices. solving mathematical problems. So if you have this is another law, p raised to power 2, let's say p raised to power m times p raised to power n. Okay, this should give you p raised to power m plus n. Okay, for example, if you have let's say 2 raised to power 3 times 2 raised to power 2 should give you 2 raised to power 3 plus 2. Okay, let me break this down. If you have 2 times 2 times 2, that's 2 in 3 places, right? Times, remember these times, okay? This is this times here, times another 2 raised to power 2, that's 2 times 2. Okay, if you count 1, 2, 3, 4, 5, so you see that once you do 2 raised to power 3 times 2 raised to power 2, you get, if you follow this law of indices, you get 3 raised to power 2 raised to power 3 plus 2, which is 2 raised to power 5. Okay, so that gives you 2 raised to power 5. That's 5 times 2 occurring 5 times 1, 2, 3, 4, 5. So there's no magic in it. Okay, that's how it is gotten. So we move to the last law of indices, which says p raised to power m divided by p raised to power n should give you p raised to power m minus n. Okay, p raised to power n minus n. So if you have something like, once the bases, these are the bases, these are the numbers, once they are the same, okay, they should be the same for these two, they should be the same. Okay, so let's say you have 2 raised to power 4 divided by 2 raised to power 2. If following this law of indices, you should have 2 raised to power 4 minus 2. Okay, remember, it's the powers you are dealing with, not the bases. Okay, not the numbers themselves. That's the index, the indices. That's what we're dealing with. That's why it's called law of indices, not law of bases, not law of numbers. Okay, so once you have two numbers, two similar numbers with their powers, so all you're doing is you're adding up. So let's take, for example, 2 raised to power 1 divided by 2 raised to power 1. It will give you 2 raised to power 1 minus 1, which is 2 raised to power 0, which is equal to 1. Okay, so you see this law of indices being applied here. Sorry, as this particular law of indices is taking effect here. Okay, meanwhile this one, this division law of indices is taking effect here.